Okay, so today we will do cover form of RC, which is in the form of ZRC, okay, ZRL, YRC, and YRL networks. Remember, when we do cover forms, we use continued fraction. Okay, we use continued fraction approach. So let's say if we are doing cover form of RC function, you are doing, let's say, ZRC, you are doing cover form for this. So remember that R can come as it is, but C will come only and only as 1 upon CS. Okay, C will come only as 1 upon CS. So actually the continued fraction expansion can be of this form, which is a constant plus 1 upon alpha 2s plus 1 upon alpha 3 plus 1 upon alpha 4s and so on. Notice that this is a constant. It means you have one resistance, then a coefficient multiplied with this. It means this is going to be your capacitance. Then again a constant, then again a capacitance, and it will continue in this fashion. Okay. Excuse me. Or you can have it like this. You can have it alpha 1 into S, alpha 1 into S, plus 1 upon alpha 2 plus 1 upon alpha 3 into S plus 1 upon alpha 4, and like this. And if I am saying that this was actually ZRC, so you would easily get that this, if it was for ZRC, then this is for capacitance. So actually this cannot be for capacitance, because in ZRC we can't have S in numerator. So indeed, either this was for ZRC, ZRL, or it was for YRC. So I told you that ZRL and YRC की जो functions या functionalities होती are almost same. Okay, so instead of wasting much time on how the form of this will look like, we will just start with a question. I'm taking the same example so that we don't have any problem or confusion in doing the partial fractions or in doing finding out the continued fraction. So your question is, let's say you are given ZRC is equals to the same question or the same example, S plus 1, S plus 3, S plus 2. Okay, this is given. And what you have to do is you will have to first find its cover 1 form. Remember when I told you that you have to find cover 1 form, you actually have to eliminate the highest degree. So अगर आप अपने ZRC को देखें तो it is something like Z square plus 4S plus 3 divided by S square. S square plus 4S plus 3 divided by S square plus 2S. You can see over here that the degrees are same, right? So क्योंकि degree same है तो directly continued fraction कर सकते हैं, or you will do continued fraction. So it is S square plus 2S. So you got of the things which are of this form. This is S square plus 4S plus 3. So if you take, let's say, only 1, so this becomes S square plus 2S. आपके पास रिमाइंडर आया 2s plus 3. तो एक्चुअली आपने अपने ZRC को इस फॉर्म में लिख लिया है 1 plus 2s plus 3 upon s square plus 2s. Right? Now you can continuously try dividing this. So अब ये जो obtain किया हमने, we can write this one as 1 upon s square plus 2s upon 2s plus 3. Okay. So you see that if powers of both numerator and denominator will be same, we will get a constant. And if power is one different, यानी यहाँ देखिए इसकी power 2s है, इसकी s square है, then we will get our capacitance system for terms like 1 upon alpha s. आप divide दें s square plus 2s को, you will get. So what I have to do it, I have to multiply it with s upon 2 anyways. Okay. If I multiply it with s upon 2, yeah, s upon 2, it will become s square plus 3 by 2s. When you will subtract it, what I'll get is s square cancel. I will be left with 1 by 2s. 2 में से 1.5 गया तो 1 by 2s. So actually, we are continuously opening it. फिर इसके बाद I will take this term inside, which is 2s plus 3. If I want to make this as 2, I will have to make this as 4. So 4 into 1 by 2 of s is 2s. I'm left with 3 only. Then I have s by 2. So if I can multiply this one with, let's say, s upon 6, we see that s upon 6 into 3 is s by 2, and it will become 0. So I've got my continued fraction of expansions. So I can write my ZRC is equals to 1 plus 1 upon s upon 2 plus 1 upon 4 plus 1 upon s upon 6. Okay. So this is our continued fraction expansion for the given ratio of polynomials in S, which is indeed a given RC function. Okay. Now it's really easy to realize it. So it is like that because we have RC impedance from it. So we will start with in series a resistance of 1 ohm. Now you see that this is a resistance, but अगर मैं इसे छुपा लूं तो then this thing should be an impedance. और impedance में कोई चीज s के साथ multiply हुई है, it means that is going to be your capacitance of value. Impedance में तो directly ये half हो जाएगा, तो half farad. But ये parallel में हम connect करते हैं. So I have half farad capacitance. Then I will have, you see that this is again 1 upon 4. So ye directly you can write as 4 ohms. Okay. And then you have 1 by 6 farad of capacitance. And this is your Kava 1 form of the given circuit or the given function. Okay. So that's how we do Kava 1 for given ZRC, YRC. Remember that Kava forms में ऐसी बंदिश नहीं होती है that you can only do it for ZRC, you can only do it for YRC. It actually depends on the approach of creating continued fraction expansion. If you are trying to eliminate the highest degree, you will get Kava 1. If you are trying to eliminate the lowest degree, you will get Kava 2. Okay. So for the same example, let us now try Kava 2 forms. Okay. Given ZRC is equals to, let me just quickly write that it is s square plus 4s plus 3 upon s square plus 2s. Actually, I've taken the multiplication of numerator and denominator separately. Fine. But in this, what we are interested in is lowest power. So आप पहले lowest power लिखिए 3 plus 4s plus s square divided by 2s plus s square. Okay. So now you can start the continued fraction, you have 2s plus s square divided by 3 plus 4s plus s square. I want to make it 3, but this is 2s, so I will have to multiply it with 3 by 2 upon s, 3 upon 2s. So if you multiply this 3 upon 2s with this thing, which is 2s, you will just be left with 3. Plus 3 upon 2s को s square से multiply करेंगे, तो you will be left with 3 upon 2 into s. When you will take subtraction, this will go. This will be 4 to the 8 minus 3 is 5 by 2s. और plus ये s square भी बचा, so don't forget to take this. Okay. Now, because I have to continuously divide, तो अब ये जो 2s plus s square will come inside. 2s plus s square. तो अब देखिए, in first attempt there was a difference in the degree. Now the degrees are same, therefore I will get a constant. So पहले मुझे capacitance मिला, अब मुझे मेरा impedance form का element मिलेगा. So you see that this is 5 by 2 into s, this is 2s. So if I multiply it with by, let's say 4 by 5, that's it. If I multiply it with by 4 by 5, I will get 2s. So this will be nothing but 2s plus 4 by 5 s square. If you will subtract it, you will be left with 5 minus 4 is 1, s square by 5. Okay. And now, because we have to take care of this one, which is 5s upon 2 plus s square. अब देखिए, एक बार 1 upon s का टर्म, एक बार कांस्टेंट, अब 1 upon s का टर्म आना चाहिए. So you will get, this is s square upon 5, but you want 5 in numerator and 2 in denominator, so I should multiply it with 25 by 2s. अगर मैं इसे 25 by 2s से multiply करूंगा, तो I will get only 5s upon 2. It will get cancelled anyways, so you will be left with s square. ये वाला s square बचेगा remainder में. Now, if I again divide s square by 5 with this, so it will go 1 by 5 times s square by 5, nothing will remain. ठीक है? So यहाँ कुछ absurd सी writing आ गई, but don't worry about that. We have actually got our continued fraction expansion for power 2 form. Okay. So we have ZRC is equals to, first write this 3 upon 2s plus 1 upon 4 by 5 plus 1 upon, हर चीज 1 upon करके लिखेंगे, 25 by 2 s plus 1 upon 1 by 5. Okay, so we have got it in this form. Now you see, आप इसको ऐसे तोड़ सकते हैं that this is a z, this is a y, this is a z and this is a y. जो 1 upon में लिखा है वो पूरा टर्म. ओके, उससे आसानी रहेगी. क्या आपको एक तो ट्रैक मिलता रहेगा कि ओके यू हैव फाउंड द करेक्ट वैल्यू, दैट so we have done this 25 by 2s should be in denominator. You see, यहाँ नहीं आना चाहिए. That's why I was a little skeptical. ये 25 by 2s ऐसे, ठीक है. अब ठीक है, तो इसे ट्रैक रहेगा कि अपॉन में ही ऐसा आना चाहिए फॉर ZRC, और कॉन्स्टेंट्स तो चल सकते हैं. ठीक है, तो इट इज बेटर टू जस्ट मेक फर्स्ट वन z, द अदर वन y, z y, z y, इस तरीके से you can try to break it. Now we will start. You see, in our form, starting with a impedance, you have first of all 2 by 3 farad का capacitance. Okay, then you have 4 by 5 ohm का admittance. अगर 4 by 5 ohm का admittance है, तो हम उसे किस में convert कर सकते हैं? 5 by 4 ohm के impedance. Remember, और जो cover forms होती है वो ladder network होती है. Because it was an impedance form, I have written it like this. Then you have again a capacitance of 2 by 25 farads. And finally, you have a resistance of, देखिए 1/5 तो एडमिटेंस रिप्रेजेंटेशन में, तो इम्पीडेंस रिप्रेजेंटेशन में कितना होगा, इसकी वैल्यू कितनी होगी, इट्स वैल्यू विल बी 5 ohms. ओके, तो ये हुआ आपका कवर 2 फॉर्म. ओके, दिस इज कवर 2 फॉर्म. Provided that the given function was, ये specify होना बहुत जरूरी है कि whether this is RC or what type of network it is. Okay, ये specify कर दिया जाएगा एग्जाम में भी, so that you are not in trouble. आपको पता नहीं, आपको ऐसे मैनुअली नहीं सोचना पड़े by using the properties of ZRC या RCRL या LC की क्या फंक्शन दिया है. How would you be able to realize it? Okay, so this is if you have impedances like ZRC, ZRL type of functions. What if you have admittances or YRC, YRL type of functions? So let us see, or just convert using the same example, and we will now say now this is YRL. Okay, so you would see that it will entirely change. So let us take another example. You have YRL given to you, which is a function of S, and it is S square plus 4S plus 3 upon S square plus 2S. Okay. I'm using the same example, don't worry. Exam में भी आपको बस ये कुछ digits ही change करके मिलने वाले हैं, और at max इनकी कुछ powers बढ़ा दी जाएंगी. But anyways, it is going to be really easy. This is S square plus 4S plus 3S square plus 2S, and this is of RL form. Okay, fine. But if they say that you have to find its Kava 1 form, you will anyways have to do division and continuously divide it. You will be having S square plus 2S. This becomes S square plus 4S plus 3. Okay, so you will continuously divide it. What you'll get is let me just copy it from we already did before. It will be 1 S square plus 2S. If I take a subtraction, it is 2S plus 3. Again, I will have to take S square plus 2S. I can just take this one as S by 2. Then I have S square plus 3 by 2 of S. I'm left with 1 by 2 of S. Then I have 2S plus 3. I can take 4 over there. It becomes 2S. It will be subtracted. You'll be left with 3. You have S by 2. You can just take S by 6. It will be S by 2, and you are left with nothing. So your YRL you have expanded as 1 plus 1 upon S by 2 plus 1 upon 4 plus 1 upon S by 6. Remember now that you have expanded in YRL. Earlier we expanded it in ZRC. Therefore, this was Z, this was Y, this was Z, this was Y. Okay, sorry, only the denominators. But now things have changed drastically. This is going to be a Y, and 1 upon Y is going to be a Z. Then this will be a Y, and this will be, this should be S upon 5, right? A Z. Fine. So you will actually start with an element in parallel and not in series. So we will start like this. I have 1 mhos of admittance, so I can write that it is actually 1 ohm of impedance also. So 1 or 1 upon 1 is same. Then you have 1 upon Z. It means in series you will have S upon 2. You see that Z के साथ में numerator में S कब आता है? When we have an inductor. So this is actually half Henry's inductor. 1 by 2 Henry's inductor. Remember RL function, it is not RC function. Okay. Then you have 4, which should be in parallel. But remember that this 4 is admittance. In impedance, it will become 1 by 4 ohms. And then you have in series a 1 by 6 Henrys of inductance. So this is RL. अब आप कहेंगे सर ये YRC भी तो हो सकता था, नहीं हो सकता था क्योंकि ZRC की प्रॉपर्टीज मैच करती है YRL से, इसलिए आप इसको YRC फंक्शन ले ही नहीं सकते थे. ठीक है, उसकी वजह क्या थी कि वी आर हैविंग फर्स्ट क्रिटिकल फ्रीक्वेंसी एज अ पोल, नॉट एज अ जीरो. तो फर्स्ट क्रिटिकल फ्रीक्वेंसी पोल जो है वो या तो YRL की होती है या ZRC की होती है. Hope you remember the second last lecture, the last to last lecture, उसमें हमने discuss किया था. So we have got Kava 1 form given YRL. We have got Kava 1 form for given YRL. ठीक है. Now we will have for the same function if we can do Kava 2. Okay. So Kava 2 means we need to eliminate what? Kava 2 means we need to eliminate the lowest degree. Again, we will keep the example same, but we will try to eliminate the lowest degree. So now your YRL of S will be written as 3 plus 4S plus S square divided by 2S plus 3. Okay. You start dividing. Try to eliminate the lowest degree. So you'll be left with 2S plus 3 plus 4S plus S square. You try to eliminate that. You got, सबसे पहले it is actually going to be 3 by 2S, right? 3 by 2S. It is perfectly fine. I can have it. So this is 3 plus this is 3 by 2S, and this should be not 2S plus. This was something else earlier. Let me just check. It was not 3, it was S square. Okay, now it's fine. So we have got 3 by 2S right there. So this becomes 4 2. So we did it actually. I can copy that. So we have now 5 by 2S plus S square. फिर ये आ जाएगा अंदर 2S plus S square. Now you can write here 4 by 5. This will become 2S plus 4 by 5 of S square. When you will subtract it, you will be left with S square by 5. Then you will divide 5 by 2S plus S square. You will have 25 by 2S. This will be 5 by 2S. It will get cancelled. Anyways, you are left with S square, and you have to divide again an S square by 5. So 1 by 5 you take as quotient, and you are left with nothing. Okay. So your YRL has been expanded in continued expression as 3 by 2S plus 1 upon 4 by 5 plus 1 upon 25 by 2S plus 1 upon 1 by 5. Okay. Now it is better to specify that this is some Y, this is some Z, this is 25 by 2S is again some Y, and 1 by 5 is again some Z. Okay. If you realize it, you will start with a parallel connection. Okay. Parallel connection, Y में 1 upon S term है. It means I have 2 by 3 Henrys of inductance. फिर 4 by 5 का impedance, 4 by 5 ohm का impedance in series. Then again 2 by 25 Henrys का inductance, और फिर 1 by 5 का, I can just complete it, 1 by 5 ohms का admittance. impedance because this is Z. So 1 by 5 ohms I will write directly. And this, because I eliminated the lowest degree, is the Carver 2 form. Okay, this is Carver 2 form. So now we have done both Carver 1 form, Carver 2 form. Remember that अगर आपको कुछ गलत information या कोई गलत question पूछ लिया है, for example, you know that ZRC and YRL have same properties and ZRL and YRC have same properties, लेकिन उल्टा दे दिया. जैसे we know that ZRC का first critical frequency should be a pole and not a zero. और आपको उल्टा दे दिया, तो you can simply say that the question given is not correct, it's wrong. Okay, so this is it, and I hope that it completes your syllabus for this course. That's it. Any doubt or query you can ask. No doubt?
सर
Yes, please.
सर YRC के लिए भी कावर फॉर्म निकलती हैं सर?
किसके लिए?
YRC.
Yes, why can't you do that? You can definitely do it. Let me just take a ZRL if it is given to me. Yeah, we can take it. Let's say it's of this form. Let me just design a question, right? So we have ZRC and YRC. I can take, yeah, S plus 2, S plus 1, and S plus 3. You see that first critical frequency here, first critical frequency यहाँ जो है वो 0 है, तो ये YRC की properties follow कर रहा है, ठीक है? And now you can try to make its Carver form. You can definitely try that. So it is S square plus 2, and this is S square plus what it is 4S plus 3. Fine. So let us try to divide it. If you will be able to. So this is S square plus 4S plus 3, and this is S square plus 2. So सबसे पहले we have a term like this, which is 1. So it becomes S square plus 4S plus 3. But when you will take minus, so it will become minus 4S and minus 2. So for the given question, अगर आप इसके लिए निकालने की कोशिश करेंगे, so it will not be possible. Let me just see. Okay, so it is correct that it should be a 2S in denominator, numerator. Don't worry. Yeah. But anyways, you will be left with minus of 2S and minus of 3. So when I have minus of 2S, minus of 3, this may not be possible for realizing it in Carver form. Okay, so there are a few questions you cannot realize as Carver form as it is, but definitely for some other questions you will be able to realize it. You can do Carver forms of YRC functions. Fine.
सर YRC के लिए निकालते हैं या YRC upon S के लिए निकालते हैं सर?
Yeah, when you do Carver forms, you don't have to do YRC upon S. For example, if you take this question, let's say you have YRC is equals to S square plus 2S upon S plus 1. Okay, I think this should work. About this is given to be as a YRC function, okay, and you start dividing it. S plus 1 divided by S square plus 2S. Okay, so it actually becomes easy when the highest degree is different by 1 at least. So you have S, you can write it as S square plus S. You are left with S again. You can write it as S plus 1. Take 1 common. You have S. 1 is left. You can take S. S is left. Then nothing is left. Okay. So what you have is you can write your YRC as 1. You see, you can write it as 1. Sorry, S plus 1 upon 1 plus 1 upon S. Okay. अब यहाँ देखिए ये छोटा सा एक एग्जांपल था. So I have got my YRC is equals to S plus 1 upon 1 plus 1 upon S. So remember that this is a Y, ठीक है? This is a Z and this is a Y again. So you will start with a capacitance of value 1 farads. ये देखिए इसके आगे कोएफिशिएंट 1 है तो 1 farad. उसके बाद एक इम्पीडेंस 1 ओम का, ठीक है, उसके बाद एक इम्पीडेंस 1 ओम का, और फिर उसके बाद एक और कैपेसिटेंस, इसका कोएफिशिएंट जो भी है 1 फैराड का. तो डेफिनेटली फॉर गिवन फंक्शंस अगर पॉसिबल है तो आप कावर 1 कावर 2 निकाल सकते हैं, बट प्रोवाइडेड कि इट शुड बी पॉसिबल फॉर यू टू डू दैट, कोई नेगेटिव कोएफिशिएंट्स ना आ जाए. ठीक है, जैसे आप अगर ये फंक्शन लेते, लेट्स से इट वाज ऑफ दिस फॉर्म, आपसे कहा जाता कि आप कावर 1 निकालिए ZRC इज इक्वल्स टू S प्लस 1 अपॉन S स्क्वायर प्लस 2S की. आपसे कहा जाता आप इसकी ZRC निकालिए, कावर 1 निकालिए, ZRC एज इट इज की कावर 1 निकालने को कहा जाता. तो यू कैन ट्राई दैट. चलिए कंटिन्यूअसली डिवाइड दे S स्क्वायर प्लस 2S, you have S plus 1 inside. Okay, so what you will have to do is you will first have to multiply it with 1 upon S. You'll be left with S plus 2S upon S. क्या हो गया 2. So एक आ गया हमारे पास -1 after taking negative here. So you have -1 now. So that's a problem. So for this ZRC you cannot take cover 1 form. Okay, you cannot take cover 1. Well, can you take cover 2? Let us give it a try. Can we take cover 2 of this? Try करके देख सकते हैं. तो cover 2 का मतलब है you have to write ZRC is equals to 1 plus S upon 2S plus S square. Okay. Yeah. So this is 2S plus S square. And you have to divide like 1 plus S. तो ये हो जाएगा, ये 2S को अगर मुझे 1 बनाना है तो 1 upon 2S I will multiply it with 1 plus फिर 1 upon 2 of S मेरे पास बचेगा because I have multiplied with 2S. So ये cancel हो जाएगा. I'll be left with again 1 upon 2S. Now this is 2S plus S square. So if I multiply it with 4, you see that it will become 2S. And I have nothing else. So it is just S square. Then I have S by 2. इसको multiply करें, ये S by 2 है, तो अगर इसको multiply किया जाए 1 upon 2S से, तो you'll be left with S by 2. Cancel. कुछ भी नहीं बचेगा फिर उसके बाद. So actually जो आपका ZRC था उसको आपने ऐसे एक्सपेंड कर लिया as 1 upon 2S plus sorry ZRC is equals to 1 upon 2S plus 1 upon 4 plus 1 upon 2S. Okay. You see 1 upon 2S plus 1 upon 4 plus 1 upon 2S. ऐसे आपने ब्रेक कर लिया. Now you see, you can simply say that this is Z, this is Y, and this is Z again. So in Z we start with series connection. So you have first of all एक 2 फैरेड का कैपेसिटेंस, C 1 upon CS की फॉर्म होती है तो 2 फैरेड का ही कैपेसिटेंस हो जाएगी. Then you have in parallel a 1/4 ohms of impedance, क्योंकि 4 था तो वो एडमिटेंस की रिप्रेजेंटेशन में था, but it is 1/4 ohms like this. And then in series of this you will have again, because it is 1 upon 2S, a 2 farads of capacitance. Okay, so that's how you can get these forms. That's it. So for a given function, there may be possible that you might not get cover or foster form if you get negative coefficients. Does that make it clear?
Yes, sir.
Okay, thank you so much. और अगर कोई आपको डाउट या क्वेरी है, then you can ask me. Probably this is the last class today. उसके बाद, if you have doubts, we can have a few doubt sessions. I will upload 3 more DHs on the classroom, and you can submit those DHs on or before the day of your CT2. जब आपका इस सब्जेक्ट का CT2 हो, आप तब तक उसको DHA परफॉर्म कर सकते हैं. Now I have to take one CA, a very small CA from the last unit, जो अभी हमने पढ़ी है. Now you will tell me when can I take that CA? बताइए. I have to take one CA. When can I take that? Or is it fine that whatever the CAs you have submitted, उसका average ले लिया जाए? Say yes or no. Okay, so I assume that you will give me CA on the day of your last CT. So for example, if your last CT is on 6th, then maybe in the evening of 6th, you will give me CA from this unit. Okay, a 10 mark CA from this unit. Thank you so much, all of you.